a new experiment, it's air conditioning system. So in the last session we have understood a refrigeration unit and refrigeration process, and we do have two equipments or test rigs which are mounted onto a single platform, and where refrigeration unit comes in handy with the air conditioning system, and we have an interfaced kind of a single unit. And if you look at this experimental test rig, the air conditioning system is very similar to that of a refrigeration unit. The process what happens in the refrigeration system is similar to that of what happens in the air conditioning system, but the thing is here we will concentrate on conditioning of an air basically. So the conditioning in the sense, we not only look into the changing the parameters or the behavior of an air, so we also change certain properties of air and make sure that the air is very comfortable to us in and around us. So the air conditioning system conditions the air, thereby altering some of the factors like the humidity, the purity of the air, the circulation of the air, the temperature of the air. So there are so on many parameters which has to be altered based on our requirement. So that is why the air conditioning systems or units are mainly meant for. And there are a vast applications of air conditioning system in industrial applications, in huge malls where the centralized AC systems are very important, and in food preserving kind of systems in a pharmaceutical industries. So there are a wide application of air conditioning system. So very simple way of understanding is only we are altering the behavior of the air, the changing the properties of the air like temperature, humidity, and so on, cleaning the air by filtering process and humidifying the air. So these are all the change of property that we are looking into it. To do that, we have a finest kind of an unit, that's an air conditioning system, which is in turn connected with the refrigeration unit, where some parts of refrigeration system comes handy for an efficient and effective working of the air conditioning system. Here, the objective of this experiment is to ensure we will conduct or we will demonstrate how exactly the air conditioning system works, and also we will look into how the thermodynamic process can be changed in this particularly for a substance called air. Right? So as we look at it, so we have an evaporator. We will be replacing this evaporator by a very simple kind of an evaporator for air conditioning system, and we have a compressor, the condenser, and a throttle valve. All the three components will be interfaced with this evaporator system, and we have a duct. We have a duct to demonstrate two kind of scenarios. One is for an open cycle system where we can just open it and air to pass through it, and we have a closed kind of a cycle system, and we do have a steam kind of a system where we can just use this particular system to release a steam, and that steam will be fed into the air, thereby changing its particular factor. That's maybe when the steam is added, the humidification process keeps on adding for that. So the steam with certain amount of heat, so that leads to an heating and humidification process can be taken place. And also we do have two thermocouples which are placed outside to measure the triable temperature and eventual temperatures, which has been mounted here at the end of this part. So to look into what is the actual the temperature of air, which is an atmospheric, and also what is the condition of air when it is saturated. And we do have certain heaters which are present here. We have individual heaters which having a capacity of 500 watts individually each, and this heaters which are used for a change in the thermodynamic process called heating the process. That is what the heat sensible heating. So henceforth, by the help of this heater plus that steam generator, we can just alter the thermodynamic process in air called the heating and humidification process. But today what we are looking at is a demonstration of this entire test rig, which undergoes an experiment for sensible cooling, right? Henceforth, we'll come back to how exactly this demonstration of this experiment is done by using one single unit, which is called digitalized system. So where we have a computerized system connected to the air conditioning unit, and the change in the air conditioning system, where the change in the behavior of the air is sensed by this system, and all the data are inputted here and manipulated, and that data can be either presented either onto the digital platform, that is onto the system, or onto the control panel. Let me look into the how exactly this control panel works with. So by switching on the console, we'll look at this, the LCD display, which pops up with a message: if PC is not connected, press cancel button to start from the panel. So we'll look into the how the readings will be displayed, or how exactly the data will be popped out from this particular system with the message up arrow for the air conditioning system. I'll go with, and I'll set an humidity, the value for this approximately around I'll go with 65, and I'll go with the enter. Again, I'll set up and what should be the output temperature of the air which has been conditioned. So I'll just set up roughly around it's around 15 and enter. Switch on the compressor. I'll just switch on the compressor here, so that the refrigerant will starts to flow within, and compressor starts to compress the refrigerant, thereby increasing its pressure. The refrigerant used here is R20, or it can also be used with R134A. So you will press the enter button. So henceforth the processing of that data takes place, and it displays a certain set of temperatures. So that temperatures, along with certain values of the input values like parameters like voltage, current, the sensible heat value, and the set temperature, and the RH value, and the pressure P1 and P2. These two pressures are at the two peak points, which can be looked here at this point, thereby setting up the air conditioning. I've started with the temperature what has distributed here. The same temperature will be popped up down to the panels here, and you can look at here. So the pressure P1 and P2, the P2 is the pressure after the compressor, and P1 is the pressure after a throttle valve. You can see the comparison between these pressures. There is a huge difference between the pressure after the compressor and after the throttle valve. This difference in pressure is what resulting in a larger amount of heat carrying the capacity, that is refrigerating effect, the heat which is absorbed here from the air. And you can see that the fresh air which is inlet at an RH value, relative humidity at 62, and which I want an RH value of 65. So it is processing at an RH value of 44, and you can look at the temperature values, how they are distributed. T1 is the temperature between the operator and a compressor, and T2 is the temperature between the compressor and a condenser, and T3 is the temperature between condenser and a throttle valve, and T4 is the temperature between the throttle valve and the operator. And you can see that there is an uniform distribution of the temperature, and you can see there is a negative temperature after the throttle valve, which indicates there is a huge amount of heat is absorbed from the air. Henceforth, you can see that the two temperatures is T6 and T8. I will concentrate only on these two temperatures. The T6 is the inlet air temperature, and T8 is the processed air temperature. That is, the temperature is reducing. Thereby, I have a set value of this is 15 degrees. This is of 15 degrees. This is of 15 degrees. What you are looking at. And there is a slight bit of typo error there. Fine, we will just see through it. And you can also see that there is a calculation part which is automatically calculated because of the data which are inputted from the physical components. You can see the variation in the particular data here. The voltage, current, and a Q is the amount of heat absorbed, and you can see the COP which will be lowered, and it is this system takes a certain bit of time to get stabilized, and COP value is well below the refrigeration unit. And this air conditioning system also working on vapor compression system, and you have HP with respect to tons and tons of refrigeration, and you have different enthalpy values which are obtained for their respective temperature T1 and their respective pressure P1. Similarly, H2, H3, H4 are all the enthalpy values for a corresponding temperature and pressures which are extracted from the thermodynamic data and book on a psychrometric chart. So we'll look into this and the theoretical calculation. Back to the calculation part. So the observation, where we will observe certain data of the physical component, and we'll enroll here. So that data are like T1, T3, T2, T3, T4, T6 and T8. All T1 to T4 represents the refrigeration cycle temperatures, which was respective between the respective components. And T6 and T8 will be the inlet temperature of the air and outlet temperature of the air. That is what objective of our air conditioning system is, to reduce the temperature, thereby changing the thermodynamic process. And the particular tabular column is not required to us. Henceforth, we are directly inputting the voltage and current values. So, and this pressure values, we have already discussed that P1 will be the lowest pressure and P2 is the highest pressure. So highest pressure is after the compressor, P1 is the lowest pressure after the expansion valve. And after that, we have certain few more points to be calculated here. That's coefficient of performance. Again, it's a ratio of the amount of heat extracted, that is refrigeration effect, to the amount of work supplied or the amount of power supplied. So the amount of heat absorbed is the difference between the enthalpies of H1 and H4, where H1 representing the enthalpy of the refrigerant at the exit of the operator, which is having a unit of kilojoules per kg, and H2 minus H1 is the difference in enthalpies that represents the amount of the power which has been supplied to it. So that is H2 is enthalpy of refrigerant at the exit of the compressor. So the compressor is what the work supplying kind of a component, and evaporator is the component which is extracting the heat continuously. So the ratio between these two gives you a coefficient of performance. And this H1, H2, H3 and H4 enthalpy values can be obtained for the respective temperature and pressure values from the psychrometric chart or from the thermodynamic data handbook. And the second point where we have to calculate is the HP per ton of a refrigerant, which is given by the same formula. So HP per ton is 4.715 by COP, which is COP which is calculated in the previous point, will be substituted here to obtain an HP per ton. And we have power input to the compressor, so we need to look into what is the amount of power that you are supplying. So to extract or to obtain that, we have a formula N into 3600, where we have to convert that into the seconds into the mechanical the transmission belt efficiency divided by the energy meter constant. So into T into 736 is what the conversion of 1 HP to the watts. So henceforth, the respective the variables are defined here in below the points, and we'll move into this, the power input to the heater. So where it is similar to that of what the power that was inputted to the compressor. Here we have the same parameters or variables which are inputted here, and we can finally find out the tons of refrigerant by multiplying the what is the power that is supplied to the compressor into the HP per ton. So that it gives you total amount of finally our agenda is to calculate what is the total amount of heat that has been rejected out for the respective amount of the power which has been supplied. So thenceforth, we have heat rejected by the air is taking a difference of H5 minus H6 kilojoules per kg of dry air. So this already I told you, H5 will be replaced by H6, and H6 will be replaced by H8. So as per our the projection of data which is obtained from the demonstration. So finally, we'll get the what is the total amount of heat is rejected. This value of H6 and H8 will be obtained for the respective values of P6 and P8 from thermodynamic data handbook. Finally, we will represent that with the results like the coefficient of performance of the refrigerant. So which will be less than 1 almost for air conditioning system, and heat rejected by air will be at some certain value of 4 kilojoules per kg of dry air. With this, I'll be closing on this the demonstration of air conditioning system. Thank you.